All right, now we're going to go over states of matter, okay? So first, what is matter? Matter is anything that occupies space and has mass. So anything that's made up of atoms is matter, okay? Which is almost everything you could ever think of. You know, your body, your books, air, a desk, a table. I mean, everything pretty much is matter. Now, one question to think about, name something that is not matter. Some things that come to mind directly would be maybe your thoughts, okay? Your thoughts don't have any weight, and now they might occupy space in your head, but they don't occupy space in the universe, if you want. So they do not have space and they do not take up mass. Another one would be light. Light has no mass to it. That would not be considered matter. But most things are actually considered matter. All right, now there's three main forms you're probably familiar with, which are solid, liquid, and gas. Okay, so let's go through those. The first one here, solid. Most of us are very familiar with this, with solids. That would be like your book. You know, you can knock on it and you're gonna have this nice, solid sound if you want. It's gonna make a noise, okay? With these, the molecules are packed closer together, okay? So we went over molecules. So we know atoms are composed of protons, neutrons, and electrons. And when we combine atoms, we make molecules. So now we're classifying those molecules. So molecules, even atoms actually have solid, liquid, and gas states. Okay, so when they're packed close together, okay, so they're really, really close, they have a fixed volume, okay? So whenever I put 10 milliliters of ice, well, actually that would be a volume, so say, 10 milliliters of ice in a cup. Let's say the cup is 100 milliliters. How many milliliters of ice did I put in there? 10. It doesn't matter if, the cup was 100 milliliters or 200 milliliters, I still only put in, 10 milliliters of ice, okay? So it's a fixed volume, meaning what you put in there is what you have. It's not going to grow or get bigger. It has a very rigid shape, so it's going to keep its shape, Again, think of your book. You could leave your book there all day and your book is still going to look like your book. Okay, so that's a solid. Then there's liquid. Liquids are not as closely packed in together. Okay, they're not, we're going to learn about intermolecular forces. These are sort of the glue that holds molecules together. All right, solid, if we think about that, solid would have very strong glue, very strong intermolecular forces. Liquid is, it flows. Okay, so the glue that holds it together is not as strong. Okay, see, it's free moving, whereas a solid is not. A solid just stays there. It has a fixed volume, so just like the solid, if I put 10 milliliters of water in a gallon of a container, okay, so I have a gallon container and I put 10 milliliters of water, how much water did I put in there? 10 milliliters, okay? It has no fixed shape, all right? So if I, put water in, the shape in a cup, it's going to take the shape of a cup, right? Now, if the cup was shaped, like a heart, well, then the water is going to take the shape of a heart, okay? So that's what it means, like no fixed shape. It's going to take the shape of the container. Now, let's think about a solid. If I put a piece of ice in a heart-shaped cup, is that ice all of a sudden going to look like a heart? No, it's still going to look like a piece of ice. So it has a fixed shape. Examples: water, alcohol, oil. All of these are liquids. Okay? And our last one here is gas. Gas, molecules have a lot of space between them. Okay? So they're very, very free moving. The glue that holds them together is almost non-existent. They go everywhere. It's compressible, meaning, I can put it in a very small container if I want, okay? force, gas into a big container or a small container. Has no fixed volume. So this is what's pretty unique about gas, okay? So let's say I put some gas in a 100 milliliter container. So how much gas do I have? 100 milliliters. Now let's put that same gas in 200 milliliter container. Now how much gas do I have? 200 milliliters. It takes the volume of the container. So you will change the volume versus a liquid and a solid. It stays the same. Gas will it'll grow to fit the size of the container. Add no fixed shape, so it's going to take the shape of the container. Examples, we have helium. Helium gas, think of balloons. Nitrogen's a gas. Oxygen's a gas. All right. So here's a summary. Here. So solid. You see this box here? So solid holds its own shape. Okay. So it doesn't necessarily take the shape of the box. Like the whole shape of it. It has a fixed volume, meaning it's not going to change. Liquid. You see how the liquid takes the shape of the container. It fills up the whole box there, the bottom of it. It has a fixed volume, meaning the volume, again, will not change. So if I put 10 milliliters of water in there, then I have 10 milliliters of water, no matter what container I put it in. Gas, though, takes the shape of the container. Okay, so it's going to take the shape and the volume of the container. All right? Do you see these gas little particles right here? Do you see that it took up the whole entire space of the container? Okay, that's because it takes up the whole volume. So that's the difference between solid, liquid, and gas. Okay, solid keeps its shape, keeps its volume. Liquid does not keep its shape, but keeps its volume. Gas does not keep a shape or keep the volume. It's going to keep whatever shape or volume you put it in. So that's going to change. So those are solids, liquids, and gases.